All right, welcome everybody. Let's get started here. I guess that homework assignment 12 you just turned in today, right? So I didn't update the slide to show our next assignment. Let's go to the course schedule just to have a look at that. It's posted on Blackboard, of course. And I think what we'll see when we look at the schedule on Blackboard is that we're really running out of time as far as this semester goes. Things are almost done. All right. By the way, this link here, Call Me on Teams, I think if you click on it, what it'll do is it'll open up Teams and then automatically call me. So that's just, if you're not familiar with how to use Teams, it's going to start up Teams on this computer, which will probably throw things off because I'm already logged in on Teams under my account up in my office. But in your case, if you have Teams installed on your computer or on your phone, you can use this link just to get connected with me. All right, so let's look at the schedule here and take a look at the next homework assignment. All right. So you've just turned in homework 12 here on Wednesday, the 10th of November. So homework 13, which has to do with inflation. We're going to be talking about inflation today. That's due on the 15th of November, which is Monday. So you've got over the weekend to work on inflation. And so the lecture that we do today, Wednesday, and next time on Friday are both related to inflation. And then you've got a little bit of a break from homework so that you can finish on the final touches for your project. So the project will be due the last day before we leave for Thanksgiving break. So I guess we'd say homework 13 due on Monday. Any questions about the announcements? All right, so we are talking about inflation today, and of course we discussed that even as early as the first day of class when we were trying to wrap our heads around the idea of the time value of money and discussing why money today is more valuable than money in the future because of its purchasing power. Let's look at a couple of illustrations of that effect. Back in 1950, cars looked a lot different than they look now. I mean, check out this gigantic boat of a car. There's 3 adults sitting in the front seat, and they're not even touching shoulders. They're not close at all. So you know that thing is wide, and you can definitely tell that it's long. It looks like there's enough room in the back for a ping pong table or something. But back in 1950, this car, the Hudson, had an original recommended sales price of $23.65. So obviously you can't get a new car today for $23.65. And what's especially shocking about that, if you think about it, is the way that things were manufactured in those days. You know, vehicles were assembled by hand. I mean, using tools, of course, but it wasn't robots doing the welding. It was a very human-intensive process, and so the labor-saving innovations that have come around in recent decades weren't available then. And so this $23.65 represented the cost of a lot of effort, the effort to get the steel, effort for transportation. Everything's more efficient now, and yet the price was so much lower than a car costs these days. And it wasn't just the Hudsons that were inexpensive. If you look at a used car ad from about that same time, here were cars as cheap as $13.95. Now this is a used car list, and so it's $23.65 for a new car or $1,395 for a used one. I mean, you still can get a vehicle for that price, although probably the Nash Tudor was in pretty good shape at that time. So why is it that things are more expensive now? Well, it's in part because there's a lot more money supply that's circulating in the economy. Today, you could spend upwards of $70,000 on just a normal gasoline-powered vehicle, and if you wanted to get something really fancy like an electric Rivian, you could spend a lot more than that. So cars cost a lot today because over time the amount of dollars are increasing, and that decreases the purchasing power of any individual dollar. And if we look at a historical graph that shows the rate of inflation from our country's founding to approximately the present, what you'll see is that in the past there were these wide swings of both inflation, and then in blue what it's depicting is deflation. So consider what that would mean. That would mean that prices are actually going down. And so here was a stretch of some decades where it was in the blue, which meant every year you'd be expecting things to become cheaper. And that, at first that sounds pretty good, cheaper prices in the future, but it has some problematic side effects that we'll talk about in a few minutes, this deflationary cycle. More recently, since World War II, the modern economic age, you can see that there haven't been any periods of deflation, and inflation doesn't have the same really high spikes that it sometimes did in the past. There are brief periods in the early 80s where it was pretty problematic, but since then inflation has been relatively low. People are starting to get worried now because inflation is about 4%, approaching 5%, depending on what part of the country you're looking at. And of course, some sectors have increasing prices that are going up faster than other categories, but people are freaking out a little bit about 4-5% inflation. And look at this graph. There have been periods where it was 30% per year. And there are some countries where they experience hyperinflation. Some notable instances of hyperinflation over the years are Venezuela, Argentina, Zimbabwe. They've all had these instances. You probably heard about it, Germany before World War II, where you had to take a wheelbarrow full of money in order to buy a loaf of bread because the dollar, well, the Deutschmark in those times had so little value, and in the evening prices would be different than the prices were in the morning. So that's hyperinflation. And we've never experienced anything like that, certainly not since we've been alive. So let's zoom in on this modern period and look at it in a little bit more detail. You can see that there are cycles, and there's a relationship between inflation and when prices are going up and when wages are going up. And so if companies are offering more money to their employees, then people have more money in their pocket, and then the prices tend to go up because if people have more dollars, they buy more things. And then the signal that the market sends when there's more demand for things is to increase prices. So these shaded blue sections are identifying some periods where the economy has gone through a recession. So here you can see in 2001, this period of recession was related to after the September 11th attacks. And then this period of recession was related to the housing crisis. There was an economic bubble that burst in about 2008. And I suppose I could probably find a new figure that would show the COVID recession that briefly occurred a couple of years ago when the pandemic began. So there's a period where during a recession the wages fall because if some companies are going out of business and they lay off those employees, then those employees are available to enter the labor market and they're willing to work for less than if they already had a job. To get someone to change jobs, you have to incentivize them with a higher wage. But if they're already out of work, then they'll work for a relatively lower salary. So you'll see that what happens is that the recession drives wages down, and then after the recession, wages gradually rise, And the bottom line is that when more people have more money, they're increasing purchasing, and that raises prices. So the first effect we wanted to identify was that price inflation occurs when wage growth is happening. It's related to demand. The second effect is that during a recession, when the economy as a whole is slowing down because individual businesses are struggling, then the labor supply goes up, and so wages decrease. So here's some terminology that we're going to be using. By inflation, what we mean is the increase in the amount of money required in order to obtain the same good or services. And so we set constant the thing that we're buying, and we just look at how much is required to get that same thing a period in the future. If we express it as a percent and annualize that change, then it's the inflation rate. Just like how we had interest and interest rate, inflation is the increase in cost, and then the inflation rate is a percentage expression of that increase. Now here's a really important thing to keep in mind, that if your savings account is only earning as much interest as the inflation rate, then your purchasing power stays the same even though you have more dollars. So think about it this way. If your bank account pays 3% interest, but prices are increasing also at 3%, when you put $100 into the bank, a year later you'll have 103. So that's more dollars, but it doesn't necessarily mean that you can buy more things if prices have gone up at the same rate that your savings did. So if a basket of groceries costs $100 today, in the future it costs 103, then you had no net increase in purchasing power for delayed gratification. Putting the money in the bank, you didn't do any better than you would have if you bought the thing now. It's not always practical to buy something now. If in the case of groceries it could spoil. But what we really hope for, ideally, is that when you put money into an investment account that you get an increase in how much you can buy down the line, that you're being rewarded as a participant in the creation of economic value as an investor. So the real interest rate is when we kind of cancel out the effect of inflation, and we find out how much purchasing power has increased by investing your funds. So it's kind of like you're subtracting out the inflationary effect. So there's a formula I'm going to show you in a moment. This market interest rate, sometimes also called the inflation-adjusted interest rate, it takes into account both the rate of inflation and some increase in purchasing power that you hope to achieve. So we previously already defined I, the real interest rate, and F is the inflation rate. So this market interest rate reflects both. So the way that it's calculated is by calculating the present value of some future amount when you're compounding not only the inflation but also the increase in purchasing power. And so since they're both inside the parentheses there, if we distribute it out, accounting for the inflation and the interest, then the market interest rate, I sub F, is the real interest rate plus the inflation rate plus the product of those two. So bank accounts usually will just quote the market interest rate. They're just telling you how much they'll pay you, and they're not telling you what the inflation is going to be or what it is right now. In fact, they probably would rather that you not know anything about inflation, because these days banks' savings rates are lower than inflation. We're experiencing 4% inflation. I don't have a bank account that's paying more than probably 1.3%. So every year I leave $1 in a bank account, it gets less valuable because inflation is eroding it faster than I'm getting more money for having saved. So let's talk a little bit more about purchasing power. Here's a basket of goods. And just for instance, what if today this basket of goods was $25? What would the price of that basket be in 15 years? So this is just find F given P. And you probably have that formula memorized at this point. Find F given P. If not, remember it's the future value is the present value times 1 plus some interest rate. Here we're going to call it F to the n power. You've seen this before, but just I called it I. In this case, the rate that we're using is the rate of inflation. So what if our current price is $25 and it's 1.03 to the power of 15? Can someone tell me what will be the price of that basket of goods in 15 years? $38.95. $38.95. Okay. So that is the same basket of goods in 15 years if every year the price goes up by 3% and it is compounding. The price increases are compounding. Okay. So $38.95. Now, what if you put $25 in the bank today? Okay, so if our present value is $25 and we put it in some bank account that pays 7%, so I is 0.07 and N is 15, let's find out how much money would we have if you save that money. So the amount of dollars you have will be 25 times 1.07 to the 15th power. So how many dollars do we have in the bank account after 15 years of interest that is compounding? Because we leave it in there and we're earning interest on top of interest. 68.98. 68.98. Okay, so did we experience an increase in purchasing power? If a basket of food costs $38.95, but we have $68.98, back at the present, we would have only been able to buy one basket of food because we had $25 and the basket was $25. But now, if our interest rate is greater than the inflation rate, we can buy more things. We could, if we find the ratio here, I think it's asking how many baskets of food can you purchase? It would be $68.98 divided by the price, $38.95. So you could buy 1.77 baskets of food if they sell them in fractions. So that's an increase in purchasing power. But it's only possible if the market interest rate, so this 7% is the I sub F. Let me clarify that. It's I sub F, it's what they pay. We had a real interest rate that's positive here. So if we solved for I, which is the real interest rate, it would be positive. Because we know, let me just carve out another spot on the whiteboard here. I sub F is I plus F plus I times F. Okay, so 0.07 is equal to I plus 0.03 plus I times 0.03. All right, so it's 0.07 is equal to 1.03 I plus 0.03, or 0.04 is equal to 1.03 I. I is 0.04 divided by 1.03. So our real interest rate, meaning the increase in purchasing power, 0.04 divided by 1.03, 3.88%. 0.0388. We have an increase in purchasing power. So every year the money is in the bank at 7%, but inflation is only 3%, then that means you're gaining 3.88% increase in purchasing power. Okay, So we've got some calculations we're going to go through for today's in-class exercise. There's an item that costs $5,000 now, so that's the P, and it's expected to experience a 4% per year price inflation, so that's F. I'd like you to determine what's the cost in 5 years, and then I give you some information here in B related to distinguishing between inflation-adjusted interest rate and real interest rate. So just practice cementing in your mind what those variables, what the definition of the terms and the variables are. Let me pull it up the way it looks in your handout. All right, I put the formula on here for you. So we want to find out how much is the item going to cost, what kind of interest rate do you need to achieve, and then how much money should be invested. All right, let's take a look at the solution for this part 1. So just as a summary, the thing costs $5,000 now, and we have an idea that its price is going to go up by 4% each year. So we want to find out how much it will cost in 5 years. Then, if we're going to somehow invest in an account that earns a real interest rate of 10%, then what sort of an account should we look for to achieve that 10%? And then applying that interest rate to find out how much we'd need to invest to be able to buy the item after 5 years. I don't know why this always comes up. All I do is just briefly hover over it. Oh geez, so annoying. All right, here it is. So this item in 5 years is going to cost $6,083.26. And then substituting it into the formula for inflation-adjusted interest rate, also known as the market interest rate. So if the inflation rate is 4% and we want to achieve 10% real return. So we want our purchasing power to go up by 10% a year. Inflation kind of erodes your purchasing power. So the overall rate of return you have to get is 14.4% if you want to have an increase in purchasing power of 10%. And so then what that means is that in order to buy the item 5 years in the future, you're not going to have to set aside as much as the full purchase price that it would cost to get it today. If you bought it today with today's dollars, you'd need to spend $5,000. But you're going to put money into an account that's outpacing inflation. The place that you're investing is returning more to you than the price increase of the item. So you only need to invest $31.04 if your investment account is going to be achieving a real rate of return of 10%. So you'll notice one of the things I did was I just kind of labeled the variables up here at the top. You know, the 4%, I labeled that as F just so that I didn't forget what it was. In the context of where you find it in the problem statement, if you label the variable there, it can be kind of a useful thing to have later as a reference. Any questions about this first one? All right. This is an Airbus 380. It is a double-decker jet. And you know, the 747 has the first front part of it is double-decker, but this is all the way through. I've only flown on an Airbus A380 for one trip, and it was really luxurious. I flew on Emirates, and that's a fancy airline. They've got really comfortable seats and great food and big screens, even for back in economy. I was in the cheap seats, and it was still really nice. Unfortunately, these Airbus A380s are not very fuel efficient because they've got 4 engines. And nowadays, the aerospace industry is moving more to just 2-engine jets because it's more fuel efficient. But let's say that an Airbus costs $340 million, and that's approximately true. If the price is expected to go up at 9% per year, then how many years will it take until the cost is $500 million? So what we're solving here is for the time, solving for the unknown time in order to have that price go up. Now, you can use the log function on your calculator to solve the problem, or, like you're going to do some algebra for this one, I think. Or you can just use trial and error. But we're solving for the exponent n. Solve for n, where the future is 500, the present is 340, and the interest rate that the amounts are growing is 9%. All right, so using the numerical approach here, we can see that it should take 4.475 years for the price to be $500 million. And the key to doing that simply is to use the log function on both sides of the equation, or you can just experiment with iterate different values of n until the result on the left-hand side is equal to the result on the right-hand side. So let's just take a look at how we would set this up in Excel if we were using the NPER function. Where our present cost is $340 million. And since it's going to be used in a ratio, I don't have to actually write the millions there. Just 340 is the present. The future is 500. The interest rate that applies here, I guess since it's an inflationary rate, I'll label it as lowercase f. That inflationary rate is 9%. So then NPER, let's use that function, equals NPER, number of periods, where we have a certain interest rate. We don't have a payment that's recurring, but what we do have is a present value and a future value. I don't know if it's going to be confused by the fact that these are both positive. Let's just take a look. So the present value is the 340 million. The future value is 500 million. It's confused because it's expecting if there's an outflow at one time, then there will be an inflow at the other. So let's just try, what if I put a minus sign here? There it goes. 4.475 to probably a few more digits, 001. All right, so 4.475 years. All right, so that's all I have for you today related to inflation. We're going to finish a little bit early for once. Just remember that your next homework assignment is due on Monday, and then really we're in crunch time for the project. So have a good day, everybody. I'll see you on Friday.